Hello, everyone, and welcome to a live special stream here tonight. Kind of unannounced. We're just getting on, hopping on, saying hi, and talking a little bit about what went down in our world today. I'm Laura Riley, CEO of Cloud Underground. This is NATO, our COO of Cloud Underground. Clouds, yes. And today we got to use the Nexus to protect our assets. Actually, because we used the Nexus, all of our assets were already protected. Essentially what happened is we have started using public cloud hosting for some of our Nexus nodes.
Scaling into the cloud.
We're scaling into the public cloud. And like almost, pretty much immediately after we started using public cloud, as happens when you're using a public cloud, we saw some unusual activity today. So we had some spikes, right? Some like activity spikes.
Well, just an attempted attack. It's just that simple. We can overcomplicate it, but it's just that.
Trying to overcomplicate anything. I am just trying to explain it in how I understood it to have happened today.
Yeah.
But it's more just like you saw the activity like spiking because you were always monitoring what's happening.
Yeah. And you see things.
Yeah, you see things.
It's hard to explain, but that's why we have a whiteboard today. Because I could try to explain it, but it is hard to explain.
That's right. So NATO's going to explain a little bit about what happened and why nothing really happened, because we have the Nexus and Blue Mira and
Yeah, so...
And actually, before he gets too into that, I will also say that if while watching this video you decide that the Nexus, Underground Nexus with Blue Mira is something that you also need, you can buy a hosted version of that from us on our website, linked below in the video description. So go check that out.
Oh, yeah.
Take it away.
So the Underground Nexus is a strange tool. Basically, we do we have a little data center, and for the most part, we have 4 different unique sites, like physical locations where that data center lives, and we have the people who run the data center. So also, I have to start there because without the people, none of this really matters, anyways. But we have Jordan of Cloud Underground, who makes sure that he's the CTO of Cloud Underground. So got to outline who's who. So we've got Jordan, who is the CTO, who basically makes sure that the cloud's working, growing, continues the development of the cloud, all that good stuff. And then we have Randall, who, as of this week, is shifting to new things that he really wants to get into. He is becoming the company's CISO, because typically, historically, in the past, I would handle security things, but Randall is taking over security things. So while Randall is sitting here learning security things, all that good stuff, and kind of getting used to new cloud setups with Jordan, got some new infrastructure, getting things set up. He's learning how to enroll people into the cloud that Jordan more or less built the general architectures of. And all of a sudden, there's something unexpected. We actually run like a 24/7 YouTube stream, so I'll just kind of give you an example. If you give me just a second, I'll just show it on the screen so that you know what I'm talking about. So if anyone has ever seen this floating about, this is actual data that is associated with a publicly scaled cloud. Now, this is my sandbox that no one else really gets access to, but because of how DevSecOps works, other people can actually work on things in this environment. And regardless of whether or not this is my little sandbox that I do on NATO as Code, on the NATO as Code channel, the Cloud Underground team actually hosts my resources. So I actually have Nexus hosting from Cloud Underground, so that I can have a more seamless, continuous 24/7 stream. And that's just something that I use to teach with all those different things, all that good stuff. But it still has to be secured. So even though I want to play with these resources, do all this different stuff, we have to make sure that it's not getting attacked. Now, before that 24/7 stream, because this stream is nothing new. I've had this running from our local cloud for a very long time, and I've been running the radio station on and off for over a year, since I guess 2021 at this point. I think I officially started it sometime in like 2020. Mm-hmm. Well, yeah, I started it in early 2020, and it got a little complicated.
It took a little hiatus, but it's come back stronger and better than ever.
Yeah, so it was the beginning of 2020 that this whole thing began. And so with us then upgrading and getting like a proper data center, it was easier to get this to run continuously. And so I run what's called the DevSecOps Dojo, where we teach people cloud basically, and teach people how to manage cloud, engineer cloud, do all those good things. So what's a good way for me to teach that is by building an actual sample item of the thing. So I'm like, okay, I'm going to build a cloud that all of you can use. You can build whatever you want in it. And then I'm also going to host an example of how that works. Well, as soon as I scaled my teaching resource and my educational resource into the public cloud, because one of the things that I always talked about is you can build locally to keep your costs down and then scale into public cloud and then have unlimited scale. It's like one of those things that I teach. But why? I've had a lot of questions of like, well, why are you building on a Raspberry Pi? Or why are you building locally?
Sorry, we had a comment. I was just looking at.
Oh, yeah. So like if we have all these different questions like where... Yeah. So it's like, why would I build on a Raspberry Pi, or why would I build in Docker Desktop, and why wouldn't I just go start building in AWS or building in DigitalOcean or Linode or Azure public cloud? If I'm building in all these different resources, then it gets really expensive, and so I build locally. And then when something is working well, it's moving into a place where I can begin to afford it, then I can get the money to then put it up into a public cloud resources. And when something goes into the cloud, one of the things that we've been teaching lately is you can't just put something in the cloud for free. Not like this, like when you want like unlimited scale. Mm-hmm. And so one of the things that we're teaching our members right now is that you have to be able to afford this. Like this right here costs hundreds and hundreds of dollars a month. It might not look like it. When we were running it locally, it did not cost hundreds and hundreds of dollars a month. But this costs hundreds and hundreds of dollars a month. So if this is costing us all this money, I didn't want to spend that money until we were at a place where it's like, okay, everything's working, everything's stable, we've gotten some strong samples. Now everyone, for those learning how to build apps, learning how to build continuous technologies, once you have it working well, flawlessly, runs 24/7, you can have it running seamlessly, and this has been running for... I don't know, we had one stream run for like months in our test, so this is already running nonstop for days without crashing or failures or anything like that. And then oddly enough, the music right here and this logo right here does run from the room that we're sitting in right now, and it hooks into the public cloud. But why is it that the music itself is also not in the public cloud? It reduced those cloud costs, because it would actually cost...
Music in the cloud is very expensive.
That's right. So putting the music up there with it would cost hundreds of dollars more than it already costs. Based on just cloud data transfers, storage in the cloud, all those different things, just to teach some people some stuff. So now that we're like at the point where we're teaching members how to scale, we're like, okay, so we're going to scale into the cloud, and we're talking about how you have to be able to afford the bills to scale into the cloud. So we got to start teaching people, how do you sell your technologies? How do you sell your apps, especially as a technical person who probably doesn't necessarily like selling. You're probably good at technology and not selling. So how do you as a technical person sell and make money? Well, lo and behold, since Jordan and Randall are watching this, Randall detected an attack in our, basically the housing, an attempted attack in the housing that this lives in, but the attack did not get inside of the Nexus. Someone tried, and one of the most important things is most people who have something in the public cloud might not even know that people are literally trying to attack you, maybe more often than you might realize, whether they succeed or whether they fail. And one of the scary things is so the average amount of time that an attacker lives in someone's environment is around something like 180 days. You can Google it. We can Google it together.
Yeah.
How long before a hacker is caught in a network?
It was in our ebook in Notion Point, but I don't remember off the top of my head anymore.
Up to 9 months. Oh my gosh, that's even worse than I thought. I was saying 180 days. 280 days, everyone. So we're looking at attackers. Well, let's make it, I guess, red or pink or whatever. So one of the scary things is we just set up the public cloud and we already know that there's some people who think that they're trying to be sneaky. And then so it's really easy for us to be like, okay, you think that you're doing something, but we see you. And then we just move you out, just get you on out of there because we don't really want you in our space. And it's real easy because we have it set up in a way to where people, like if they try to attack our ecosystem, it has like a vacuum space around the Nexus. So if someone gets into our network, I'll show you what it looks like at a high level. But there's only one port that opens up to the public cloud, so they have to try to get into this one single open port. And then if they try to find some other way, like say maybe they breach DigitalOcean to get into the Nexus, they might actually breach our bare metal host, but they still have to get into the Nexus. Just because you hack our host doesn't mean that you can get into the Nexus. So if DigitalOcean gets attacked, now if they do anything, our traffic, like if we're typing in passwords and doing things from within inside the Nexus, is encrypted. They can't really see what we're doing. But anything that they do to the Nexus from even inside our host is 100% exposed. So if they're trying to test passwords or trying to do things, we can see their passwords that they're entering and their keystrokes, every little thing that they're doing, what they're looking at, what they're checking out. And we can just like cherry pick that, and use that to keep us safe.
Would it be safe to say that instead of it taking 280 days, obviously, it took us like less than 280 seconds to realize, like...
It was like immediate.
Yeah, I mean, it was certainly less than 280 seconds would be like 6 minutes or something.
Just get that message and it's like, we're under attack. And I'm like, what? We're under attack. I like look at
we knew
my
much
phone.
faster than 6 minutes that there was something.
I'm like what's going on? I like see the spikes, and then everyone drops everything, and they're like, all right, so like, what's one of the secret sauces? Yeah, monitoring. That's the secret sauce.
And DevSecOps, like this is what DevSecOps is and what it's for. Is like we already had the system in place to be able to detect them. We were already safe because of the way that we've set up our whole system from the get-go. Like it's all DevSecOps essentially. This is the security part of DevSecOps, but it's all there, and that's why you need it.
Like ultimately, your code is your company in the online world. If you're like a banking company, your banking systems and all that stuff for the transactions, your code. If someone gets into your code, they get money. If you're a software company and someone breaches your application and makes it to where vulnerable stuff is being leaked out, that's your company. Your code is your company. So if you're not thinking about the security of your code like before it's even put out into a public cloud location, to be fair, I will say that the resource is being tested for about a week before recon attempts started trying to catapult themselves into the Underground Nexus's public resources up in the public cloud. But it really comes down to we structure the Underground Nexus, and I'll show you how it's structured, that even if someone were to completely breach into this, we still cache our most important information away from our primary front end like system that everyone sees and accesses. So if someone were to even get into this, there's a whole journey involved with it's actually just much harder to hack. I mean, anything can be hacked. I'm saying that as a cybersecurity professional. If you see marketing, they're like, unhackable software. That's probably a liar.
It's like the Titanic. They said it was unsinkable, and look what happened to them.
Yeah, well, we're not claiming that what we have is unhackable. What I'm saying is all your war tools are right here with you, like your spears, your shields, all of it. It's all right here, so you can be like, I see you. You ready to go? Let's go, because they're coming to those gates. Like, it's just kind of how it happens. It's just no ifs, ands, or buts. Someone's coming to your gates, and they're going to be knocking on your doors. And so, regardless, we have different tripwires. So I'll just kind of show how does the Underground Nexus work. The Underground Nexus is very odd. So, what in the world is the Underground Nexus? That's a very good question. I've wondered what the Underground Nexus was since before I made it. And then the next thing we know, we had this thing, and we were like, what should we call it? I guess we'll call it the Underground Nexus, and that's kind of what happened. It was originally called the Life Vault, and it's based on a tool called the Olympiad. And the Olympiad actually is a resource that lives inside of it that I maintain myself. So what in the world is the Underground Nexus? It's a jellyfish. Maybe it's not a jellyfish, but it is. It is, though. And I'm going to show you what I mean when I say it's the jellyfish data center. So the Underground Nexus is a copy-paste data center. Let's kind of maybe get into that. The first thing to be aware of is if you're not trying to work with data center technologies or build a data center or host things that you would need a data center for, people are like, well, what would I do with it? Well, if you don't have any need for data centers, or if you don't have a goal to work like in a data center, then the Underground Nexus might not be something that you care about. But if you're also trying to, say, like build a web app or cloud hosted something, and you're trying to reduce the cost, especially if you're an entrepreneur, a lot of entrepreneurs end up having to care about what a data center is when they're the one who has to pay the bill. And so if you have people who work on data centers and you're not the one who works on the data centers, but you see that bill, if you see that bill, you know what that bill looks like. That bill it's a big bill. It's most likely a big bill. It's like at least tens of thousands of dollars, because even on the low end, spending like $70,000 a year on your cloud resources when you're scaling to like thousands of users, that's pretty cheap. We scale to thousands of users, viewers, and all that stuff, and it costs money, whether you realize it costs money or whether you want it to cost money or not. It all costs money. So how do we make this Nexus resource work? So it kind of starts, if we were to talk about, I'm going to talk about the ultimate Nexus, but I'm going to start with how do you start with it. So the Nexus begins with local MVP systems. So you might have a bunch of developers, right? And these developers are like, we're going to build a new app the world has never heard of. The Nexus is actually free to just use. You can use it for free whenever you want. It's not going to cost you anything. The Underground Nexus, I don't know if I have a link to it, but I'll find a link to it. Actually, there is a link to it.
There is a link in the video description as well, if you're watching this video.
Wow.
Nexus.
Yes, you don't have to pay money. And we do have overall architecture docs on what in the world is going on with the Nexus. So at a high level, you can kind of see what in the world it is. The Nexus, as you can see, it's designed for running continuous apps. This is showing sort of like a sample screen where this is showing this thing on the left is an Underground Nexus server, or at least a tablet turned into an Underground Nexus cloud server
The other beauty of the Nexus is you can basically use like whatever machine you've got lying around to deploy your own Nexus if you so want to do that.
And this one server right here
Build your own.
is streaming to this global, it's streaming this global 24/7 app here, which is a radio streaming app. And then it's streaming 2 desktops where I have this showing, even though it's one computer here, I'm just connecting 2 browsers here that are split side by side. So this is one user's browser session, this is another user's browser session, and this is a 24/7 continuous streaming app, and then this right here is the Nexus. And you can configure it so that it's globally accessible. You can use VPNs, you can configure TLS resources if that's your thing, even though I hate dealing with SSL certification rolling, but it is what it is. Technology, right? Security first. Otherwise, if you're using a VPN, then that's an option. But there's a whole architecture diagram. It shows the high level for, what are some of the core apps that make it what it is. It has Kali Linux living inside of it. It has S3 resources from AWS. If you've ever heard of an AWS S3 bucket, it's for data management. And then it has different desktops living inside of it. If you've ever heard of Portainer, it's got that for overall container management. And then it has Pi-hole for your DNS and DHCP monitoring options and resources. And by default, the Pi-hole monitors and manages the DNS for every single default Nexus app, period. On top of one of the stranger features of the Underground Nexus is that it can emulate virtualization. So it can emulate virtual machines. So if you're trying to run something that requires like an actual hardware virtual machine, or let's say that the Underground Nexus is running on a Raspberry Pi and you need to run AMD 64 software on a Raspberry Pi, you can run AMD 64 VMs on this thing, which we're testing the stability of those. But either way, you can emulate VMs, whether it's something that's an entirely different architecture or the same architecture as the host running the Underground Nexus. And then it's just a terrifying stack. So it's got a whole lot going on here. There have been a lot of additions to it. One of the most notable ones is, if I can find it, Terraform. One of the most notable additions to the Underground Nexus is Terraform. And there is an actual walkthrough on just like how to get started with the virtual machines if you're trying to learn how to launch emulated virtual machines that don't actually require virtualization but emulate virtualization even if your hardware doesn't have virtualization. That's a mouthful. And thanks for joining in as well, everyone who's jumping in. I appreciate you guys checking out the stream. We've put a lot of work into this. So then, like I said, it's got Kali Linux running inside of the ecosystem with Terraform and Metasploit together, which means that you can not only build payloads, but you can use Terraform to like auto-construct entire payload structures, which is I don't know if that's a good or a terrifying thing. Probably more on the terrifying side.
Definitely.
But let's say these local MVP systems, it could be a Raspberry Pi. So let's say one developer is using Raspberry Pi Nexus. And then let's say another developer is using a Docker desktop Nexus. And then let's say that another developer is using something entirely different. Maybe they are using Ubuntu Docker Engine Nexus. Or, I don't know, it could even be like Parrot OS. Doesn't really matter. As long as it can run Docker and Kubernetes, Nexus is based off of Docker and Kubernetes. It uses Docker to build networks and load balancing for Kubernetes apps, and it lets you model and build your Kubernetes apps, and so it also deploys Kubernetes by default, and it uses Kubernetes for scaling, so it doesn't use Docker for orchestration, but it does use Docker Swarm for overlay networking, and then there is Kubernexus that lives in the Underground Nexus, which is basically K8s. So it's fully certified K8s live inside of the Underground Nexus, which you can pipe out to any other flavor of K8s. So let's say that you have Kubernetes like Minikube or the Kubernetes kind, like Kubernetes and Docker, or you're using just conventional Kubernetes from Google, doesn't really matter. You could even be using Azure Kubernetes or DigitalOcean Kubernetes. The Underground Nexus can actually scale and load balance out to present your Kubernetes applications where you have essentially managed network layer for load balancing and distributing. It's kind of like a load balance proxy. It's kind of confusing. So this is where we're getting into technical weeds. This is why Laura talks first before I say anything, because everyone loses everything I'm saying when I start talking. So we have all these developer systems, and now let's say that the MVP that these developers are building is ready for hosting. These locations can actually, let's see, I'll choose green. So you can start hosting an application from the Underground Nexus before scaling it into public cloud, straight from its MVP state, where you can actually cluster an overlay network for your Kubernetes to talk across between all your systems. So I'm going to choose a color for Kubernetes, I guess, which will be blue, I guess. So this is a Kubernetes link here. This is a Kubernetes link here. So we're just going to say that Kubernetes can cluster across all of these thanks to Docker. Or you can just have a Docker network that allows these all to talk whether or not you're using Kubernetes yet. And then all of your hosting can then be centralized over a single point of presentation, I guess. So like a single presentation layer, whether that be an additional brokering node, or it could be something in the public cloud. We started by having, we have an AI mesh, and our AI mesh has basically nothing but a VPN layer in our distributed hosting. And then our it's really confusing. Our VPN layer, every single VPN host is a proxy gateway that load balances across all of our physical locations. That's really confusing. But they all talk together. There are products that you can see do this called like VPN Fusion. You can Google like VPN Fusion. There are different products that have things like that. You can manually configure this exact same kind of thing. It's basically like building a weird sidecar proxy configuration with a whole bunch of VPNs, where all of the VPNs have their own unique VXLAN except for the central VPN, which is where it gets real confusing. So anyways, this is where we have all these different distributed systems. And then let's say that you need more compute than these systems have, and you're like, okay, we need a lot more like pipeline. Like we need a lot more bandwidth, a lot more networking. When you get more users, you need more compute. You need more bandwidth for like network speed, all those things. You need more RAM. You need all those things for all these new users you might want to enroll into your cloud. So the next thing that this brings us to is we get to scale. You can scale to public cloud, where you can set up so we could give an example of like maybe you use DigitalOcean, even the low-powered nodes, because we modeled on a Raspberry Pi as the minimum hardware that it'll run on. So you can actually run the Underground Nexus in low-powered cloud compute if you're trying to save some cash and still use the Nexus on a 24/7 basis. You don't have to go and get the most powerful compute, because more power means more money, unless you need to run a really beefy app. Then it just depends on what your app's doing. And if you built it, then you know what systems it's going to run on. So that's kind of up to the person. All this stuff. This question, thoughts on Istio. You know, I think Istio, especially for B2B projects, is great. When you're trying to move quickly, because there's a question about Istio. I was talking about you can load balance in different ways, and Docker can load balance and all these different things. For those who aren't familiar with load balancing, one of the load balancers that exist out there, you can look it up. It's just Istio, because we're also on YouTube for those who aren't over on LinkedIn. Istio is from Google, and it works really well with resources like Kubernetes, especially resources like Kubernetes, which is kind of a nightmare sometimes to load balance. It's AMD 64, unless I think they started having an ARM instance of it. But I would say of the paid services, especially, if you're like, am I going to pay for which load balancer? I would put Traefik and Istio as some of the top like 2 paid load balancers. And even if you're not using the paid versions of them, they're still really nice. But if you're trying to move fast and you have cash for it and you have more money than you have more time, then I would say Istio is a great way to like move fast. So if we're scaling into public cloud, you could even actually use tools like Istio with, it doesn't have to be DigitalOcean, that could be like Google Cloud Platform. Or whatever, it could be anything, because Underground Nexus will run on anything that will run Docker or Kubernetes compatible applications. So now that we're getting into this idea of distributed hosting, let's get our green marker and draw our scale up into public cloud. Now the cool thing about public cloud is once we have a resource in public cloud, we can have it. Basically, we can scale to Kubernetes. And then if we scale to Kubernetes in public cloud, or it could be local too, but since the Underground Nexus itself is Docker based and it runs out of a Docker container, it's important to know that we don't use the Docker container particularly for the orchestration. We use the Kubernetes resources for the orchestration, and we actually use Docker for isolation and managing the load balancing resources, all that good stuff, for making it so that you have maximum control over where you want your Kubernetes to be pointed at in whatever direction. You can make your Kubernetes also scale some of the resources from all of these other systems here. And because of the invasive nature of Kubernetes, which makes it both great and terrible, if you have never used Kubernetes before and you didn't realize that it can be overpowering, it can take over your ports if you have other applications running on things. And so without using the Underground Nexus and you're trying to develop and run Kubernetes applications on your systems, Kubernetes oftentimes is going to just like strong arm your ports. It's going to be like, give me that port. You have that port? Wow. It's going to knock that port out and it's going to take over that port. So Docker helps prevent that so that you can actually scale your Kubernetes hosting. Mind you, the Underground Nexus also isolates Kubernetes hosting from the bare metal so that you don't have Kubernetes running on someone's like local homebrew machine, even if they're helping with some of the hosting. It's all separated, isolated. It's a little confusing. But anyways, we are at the point where at this point you just scale how much scale you want. You can scale as much as you can afford. You could throw $1 billion at it if you can afford it, and you can scale $1 billion worth of scale with your application this way. Or you can throw $10 at it, and $10 won't get you much. $10 won't get you much. But you can pretty much just then scale and support as many customers and consumers as you can generally afford. And then you can also scale out your developers' resources because those MVP systems become developer systems at that point. So because that's where it all began. So you have your dev systems. And then because the Underground Nexus is built for developers at the end of the day, it allows you to make your developer systems or designated developer systems also contribute compute, which means that if you're trying to sandbox or you're trying to do like develop something else up in the public cloud, you could have all your developers go and develop things in their own public cloud nodes, but that's going to cost a lot more money. You can absolutely do that, if you have the money. But what if you don't have the money and you can at least afford to scale to your users, but you can't necessarily afford to scale development resources for your developers? Fortunately, because the hosting is fully distributed, people can develop away from the public cloud and load balance back up to the public cloud. And so we do it this way because, like, what if an attack does come? So the cool thing about this is if we suddenly do have some giant attack that just like swoops in from the sky, I guess we call it the cloud, I don't know, comes wherever it comes from, wires through the web that either run in the dirt, really. So why call it cloud when the wires probably don't go through the sky? Anyways, I digress. We actually do use a satellite node as well for our scaling, so we even scale out the satellite thing. But let's say we get attacked. And let's make this attack marker red. If someone should decide that they want to come over here and attack your Kubernetes, and then maybe even attack your public cloud hosted Nexus, one of the cool things about it is all of your sensitive information, if built out appropriately, all of your secrets, all that really critical information should be running away from the cloud and networking into the cloud over your distribution layer. And so if you're getting attacked, chances are your public cloud is what's easy to scan, because people, I don't know if people have heard of, like, go to leakix.net, or maybe don't go to leakix.net. It may or may not make your system vulnerable. But go there anyways, but maybe think about how you go there. I'm just going to put a tile that says leakix at your own risk. Leakix.net at your own risk. Yes, I am literally telling you that I do use resources that might actually cause you to get hacked. So be careful when you use things. You can actually probably access it from the Nexus if you want a way to go and look at strange sensitive websites without it hitting your like local machine. So you can spin up a Nexus node if you're kind of scared to check out some of these things. But if you go to a website like Leakix, you will notice that all of the information, as soon as you can spin up a DigitalOcean node or an AWS node or some other node, and you can identify its existence once it starts popping up on things like Shodan too, where all of a sudden it's like, boom, okay, look at that, there's this thing. And so since there are people constantly scanning the internet, for good or for bad, there are people who try to get there before the bad guys, but the bad guys use the same tools as the good guys, so everyone's in a race to take somebody down for whatever reason, get some cash, take some people out. I don't know, everyone's got their reasons for why they attack somebody. Don't attack people. But those who do attack have reasons, especially if you're defending against them. So, but when someone does see these things and they're now on this full-on assault out to your public cloud resources, if you've been building the Underground Nexus where it's pretty much underground, cloud underground, right? Underground clouds. Anyways, if you've been building your infrastructure to where it's anchored and rooted with these scalable kinds of resources where you have local Nexus nodes where people do their development away from the public cloud and host their keys, resources like that, sensitive resources, pass resources, put that away from the public cloud and have encrypted transmissions going back and forth between your communications, your whatever, your stuff. But keep it encrypted, keep it clean, keep it safe. But as you can see, if you attack the top of the jellyfish, I guess if it was real jellyfish, it would just die. But either way, the Underground Nexus, it's shaped, I think of it like a jellyfish. Kind of looks like a jellyfish. It's got like, you have your public cloud, that's where you have your big scale, all that stuff. And then like you have all the little tentacles that go down to your little developers who are just doing their thing, you know. So that's our Underground Nexus. It's the jellyfish cloud. And I guess there you go. It just keeps your really sensitive stuff off the public cloud. And so really someone could actually just take the resource down entirely, and while it might be a little annoying, sorry, let me correct myself. All of our most important critical resources are down across multiple sites. You have to attack multiple physical locations to take down our infrastructure. And I'm not saying that anyone should do that. Please don't attack us on purpose. But anyways, I digress. It's DevSecOps, and anyone can use the Underground Nexus. It's when someone comes in and attacks one of these items and you're in the public cloud, the idea is that you have as few public ports open as possible on the public cloud, and you have everything encrypted over VPNs, VXLANs, all that good stuff. And keep your stuff safe.
That's right.
Yeah, so it's key, build
Use the Nexus.
Yeah, build your projects
Like we do.
safely from day one. Unlimited scale. Start with what you can afford. Scale up as you can afford it.
Build security from day one. That's DevSecOps.
You might have $100 to start a company, but one day when you have $1 billion to scale out, and I don't know if you have $1 billion, but like, it's not unheard of to generate, $300,000, $2 million, to start having to come up with money to start paying for scale. When you start getting to the point where you're like, oh gosh, I have more customers than I know how to manage, and I have to keep it all safe. If you started building for scale from day one, you're already ready to just continue to enroll unlimited customers. Really, the Nexus is built for just enrolling unlimited customers with the minimal amount of centralization. Start with like the smallest nth, so that instead of like sizing a server up front where like this server has to last me for 5 years. Nope, no more of that. Migrations, you don't even have to worry about migrations. Most of everything lives in Git. Even our web app hosting. So you can actually build the VPN tunnel that we have. You can come over here to the web app hosting for the Underground Nexus if you wanted to build a public cloud tunnel for your Underground Nexus. You can build different ones, so this is just one way to learn how to do this stuff. This one right now is using a resource that you might want to double check and just make sure that you understand the security of using this resource. Don't just blindly use things. Don't even blindly use things from me. Check all of the code before you deploy it. Check it. Check the code. Don't just deploy things. Security. Think before you leap. That's right. So anyways, we don't have to do security at the end of the process after we build everything. We actually got attacked before things are even remotely close to being situated in the public cloud. But hey, we already had security from day one, so I guess it's not so bad.
Not so bad.
How scared do you feel right now that people tried to attack us?
Not very. We knew it was inevitable. We knew that scaling to the public cloud, like, if you're going in the public cloud, you're going to have some more vulnerabilities. So
if someone
it's
asked,
kind of just the nature of the
is
game.
it a wolf? Is a cliqueye? The little crazy thing.
He's finally calmed down.
He's like, I am done squirming.
He's like, nope, never.
He's kind of like
never done.
A tiny wolf. He's still a puppy.
But
he's not going to be big.
Small, sleepy doggy.
I guess we can get both of them.
Yeah, bring Augustus up too. It's been a while since Augustus got to come on stream too.
Yeah.
He was our mascot for so long.
Well, he still is our mascot.
He is our mascot still.
We actually have
but we
AI
haven't
named after him. Oh, Augustus. Go right there. Go.
Our AI Augustus bot.
Yes.
Here's the namesake. Here he comes.
It's AI Augustus.
Augustus.
But the real one, he's here.
There he is.
He is immortalized. And like, he's very tired.
Yeah, both doggies are tired. They're like, it's so late, guys.
Augustus is actually bigger than this one's going to be.
Yeah, this is Apollo. He's 6 months old. He's tiny. He's a tiny, tiny doggy. And we found out that Augustus is like a giant cliqueye.
Yes,
he's
Augustus
22 pounds,
is as big as they get.
Which is massive for a cliqueye. And Apollo here, I don't think he's going to be more than like 15 pounds. If he's lucky to even make it that big.
He's worn out. He's like, I'm ready for bed.
I'm sleeping now.
They're both tired.
I got all my energy out.
Well, I think it's time for doggy sleepy time.
Yeah, thanks everyone for joining us on a late night stream where we were able to talk a little bit about the activities of our day and why we're not concerned too much about it because of the Nexus.
We use the Nexus and it's organized and we monitor things. If someone attacks us, we'll respond real fast because
it's inevitable.
You're going to get hacked. if you run a company online and you think that you're never gonna get hacked, I'm sorry.
You're naive.
It means you're either already attacked and you don't know it, or it just hasn't happened yet and you just
and
been
you're
real
gonna be
lucky.
sorely unprepared when it does.
Yeah, but if you already know you're gonna get attacked, you just get prepared, and then when it happens, it's like, oh.
Then it's not as scary or shocking.
Yeah, just like tell them to go away, and then they get rid of your attackers.
That's
so,
right.
Cool. Well, thank you everyone for watching.
Thanks, guys.
Appreciate you.
The dogs say goodnight.
Augustus appreciates you too. Good boy, Augustus. Oh, he's like, oh, you said my name. Yes, we did say
my
it.
name.